Good morning. I experienced several affiliations and several research activities and collaboration work with the medical department. And now I belong to Kogakuin University. Kogakuin University has established Mr. Hiromoto Watanabe, who is the first president of Imperial University of Japan, made variety of societies to make communication among multidisciplinary fields. He established Kogakuin University, which is one of the societies for education of engineering. You see it in the slides, Kogakuin University is located in 2 campuses. In Shinjuku campus, at Shinjuku campus, you can view Mount Fuji behind our skyscrapers, and behind our building, there is a City Hall of Tokyo Prefecture, and we welcome you for Olympic Game 2020. Our university has several kinds of laboratories related to biomedical engineering. And we have a very nice research center for micromachining and cell culture, so students enjoy their research life. And we have a nice collaboration with sister universities, School of Medicine and School of Pharmacy. Today's topic is communication training in multidisciplinary field related to biomedical engineering and symbiosis engineering. If you look at communication training, diversity, communication tool, and case study and presentation will be a keyword to this topic. We are now living in an internet age and supported by big data. So we'll have more and more diversity with culture, language, generation, so on. If you look at biomedical engineering field, this field is not only related to science engineering, but biology, pharmacy, medicine, and also economics, sociology, ethics, and religion. If you look at technical term of symbiosis, it is the origin is biology and living together. The slide shows clownfish and sea anemone. But if you look at a microscope, the biological cell itself has symbiosis with mitochondrial. And the left side shows the cell culture on engineered spring to make a hybrid muscle system. So the symbiosis is not only between biological system, but between biological system and engineered system. We talk about 8 topics in this talk. Base of engineering, finding topic, and finding related subject, and the general background, and proposal, and cross-culture, and internship, and presentation. And these topics are supported by experience in these 40 years. Mahidon, Churankon, Kogakuin, Kansai Medical, Kitasato, and UIC, Osaka Institute of Technology, and internship between universities. Let's start with first one, base of engineering. The student project design of a system which is a movement, and the student enjoy their group activity, project-based learning to make a movement. And this topic is not only related to mechanics, but also related to electronics. So already interdisciplinary studying, learning has been started. And topic 2, finding a topic. The student now discuss in the group and to pick up the topic related to medicine in future. And they took keywords and they discuss about what is the contribution to the society in merit and demerit. And after the discussion, group discussion, each group made a presentation, and these 10 items shows the topics which picked up by student group. And I found that many topics are related to robotics and telecommunications and artificial intelligence. And let's move to number 3, finding related subject. This biomedical engineering field is very complicated and related to too many academic fields, so students should understand the background of this multidisciplinary field. So students find related subject. This time, every group should take the example of artificial organs. And after group work, each group made presentation. And in this short course, several research academic field has been introduced to the student. Biomechanics, biomaterials, and rheology and electronics. And at the end of the course, students make a short report and image a device which operates as a part of the human body, and image programs to be solved to design the device and list up related subject. It is very important for them to begin the biomedical engineering study course. And let's move to the number 4, engineering background for biomedical engineering field. In this course, the contents are chapter 1, organism and machine. So students find out what interdisciplinary is, and learn about the unit and measurement, material. So case is hemolysis, and flow chapter. Case is blood circulation and energy, oxygenated dialyzer and movement, joint prosthesis, and design and machining actual organs. And in this course, I picked up some technical term between medicine and engineering is the topic. Control is the example. What is your image from this technical term, control? What? If you learn about engineering, adjustment and regression is the meaning of control. But if you come from biology side, the comparison is the meaning. How about plasma? If you learn physics, electrolytic dissociation and ionization is the meaning of plasma, but it means supernatant of blood from biological side. So technical term sometimes makes communication mismatch. Also, each discipline has philosophy, and I experienced 2 times doctor thesis interview. And at the medicine, repeat and the statistics is very important. And engineering, standardized is very important. Because organism has individuality and data depends on time. But the machine should be more and more standardized. So temperature control or material purification control is very important. And also students should learn about unit for the numbers. This is a very strong tool for international communication. And at the end of this course, each student should make a report on one of the topic related to biomechanics or biomedical engineering. And the report should include quantitative discussion with numbers and equations, and student should draw figures for explanation. That is training. And let's move on to the number 5. Proposal. Proposal on biomedical engineering. Design a new device is a question for the student, which acts as a part of the human body. And describes the specifications, including original drawings and numerical description. The description should include problem to be solved, method, background reference, and expected result, and the contribution to the society. And the student now are discussion about what should be the topic. And after the discussion, each student make a presentation, and against the presentation, audience make a question and discussion. And left low table shows the topics taken by student, and it is related to a sensor, AI, prosthesis, and human engineering. And this is a real case of topic which picked up by student, related to sensor, speech, eyes, teaching machine, sensing of vital signs, or so on. And related to AI, running suit or implantable micro machine, or so on. And related to a prosthesis, actual vision or navigation system or so on. And human engineering, dielectric current watch, or so students enjoy to seek the topic to be solved in the future. And this figure shows the example of glasses with additional function, and the students make drawings and they enjoy the thinking about the topic. And another student picks up the navigation device. And let's move on to the 6th item, cross-cultural. Cross-cultural student workshop. In that workshop, a student make a group and enjoy group work. And after group work, each group made a presentation. And the biomedical engineering course is very nice to make diversity, because the student background is mechanical engineering, electronics, material, control, informatics, medicine, nurse, dentist, biologists, veterinarians, many backgrounds they have. So there are very nice variation to make a group and experience diversity. And the table shows a number of students who participated in this workshop every year. And if we look at number 7, internship. Kogakuin University welcomed several internship students from Mahidol University, Thailand, and National Institute of Technology in Japan. And they experience cross-culture because the background is different, and the nationality is different, culture is different. And the right slide movie shows the presentation of final report of internship. And he really enjoyed not only the academic life, but also the Japanese culture. I myself experienced internship abroad in 1977 in West Berlin at the Archer Organs Institute, and that experience gave me a great shock and a great motivation, not only for research work, but also education activity to the student. And the final one is presentation. The student making a presentation, Japanese, in this case, Japanese student making a presentation in Mahidol University in Thailand. And for the Japanese student, for him, it is the very first experience to make an English presentation. But it was very nice because he uses equations or figures or very nice slides, so audience can understand what he's saying. And another one is presentation training in University of Illinois at Chicago. And even for him, he's not so good at speaking English, but he made a very nice training. And also in Kogakuin University, we have an international conference every year, so students can enjoy and experience English presentation in our campus. And about this conference, I attended 2,000 at the first time. And the table shows the number of students who participated in this conference. And almost every year, students experience very nice experience in this conference. And this year, also one of the students will experience English presentation in morning session. And in this session, every student show the result of the research, excess gravity or dielectric phoretic movement or microgrooves technique or microslit technique to observe the deformation of biological cell, and also the migration of cell observation in the shear field. And this table shows the number of countries which are listed in the proceedings book of this conference at WMSCI. And in my sense, the number is rather high compared with the peer-reviewed, specialized international conference. So it is very good stimulation for young students to join in the multi-society, and WMSCI supplies multidisciplinary society and cross-cultural society simultaneously. And this table shows communication training and a case report. And in the last of my talk, I picked up several things in nowadays. We are now supported by data. And if you look at the imaging technology, we can make data recovery but sometimes data recovery make fake. And this technique is very important for medicine to observe the details of our cross-sectional of our body, human body. So immunostating technique or cartilage of new joint technique by MRI is very nice, but sometimes the data might be fake. And also the resolution of time is sometimes makes trouble because our eyesight has a limit of sensitivity. And also the second topic is networks. We are living in network society. So network society will make self-monitoring system. So do we need hospital or we don't need hospital anymore? But who think about the security or privacy? I'm such kind of a member of the committee. And young people must fight with multidisciplinary topics in this field. So I made a question to the student. Do you prefer AI than medicine for diagnostics? And most of young students make answer yes. But in my sense, who takes responsibility of this world? So from my talk, communication training problem is not depends on the language, not only depends on the language. The movie shows the Thai language class for Japanese student in Kogakuin University, but we engineer should take more and more mathematics in internship communication tool. So this was visiting laboratory, students enjoy that, and also visiting department, students enjoy that. And international collaboration support this talk. And I don't know the details, I don't finalize the details, but from the student report or when I make an interview to the alumni, student tells us most impressive experience during student age was this course, and this course made very nice motivation to the student and the elevated skill for interview to finding a job. And you know, in Japan, most of young students prefer to stay in his house, but this course breaks the shell and teamwork. And DRSU is thankful to Professor Siripon, Damron Sakul, Dr. Jack Reed, Nora Seth, Robert, Shu, Richard, and Tom. Very, very thank you. Thank you very much.